This is Module 4, Lesson 6. We're going to do a second round on types of solutions just to make sure that we all understand them. We're determining whether a linear equation with one variable has one solution, infinitely many solutions, or no solutions. If it has one solution, it's going to look like x is equal to a. An example of that would be like y is equal to 3 or m is equal to 2. If it has no solution, it's going to be like a is equal to b. The example would be like 3 is equal to 4, negative 6 is equal to 8, something that can't work. An infinite number of solutions would be like a is equal to a. The example would be like 6 is equal to 6 or negative 3 is equal to negative 3. Okay, so in the workbook, let's go to page 61. Okay, there's page 61. Now we're going to solve each of these for the value of x. In this case, we've got 7x minus 3 is equal to 5x plus 5. Okay, we want to see whether there's one equation, whether there's one solution, no solutions, or an infinite number of solutions. We start out by solving this equation. And if I'm doing that, let's try to bring all the variables onto one side. So I'm going to subtract 5x from each side. That would give me 2x minus 3 is equal to 5. Let's add 3 to both sides, and I get 2x is equal to 8. Divide both sides by 2, and x is equal to 4. Okay, that is one solution. Let's try this side. I've got 7x minus 3 is equal to 7x plus 5. Now we can tell right now there's no solution to this because there's nothing I can plug in for x and make these be equal to each other, because 7x is your 7 is your coefficient here and coefficient here, and there's nothing I can subtract 3 from and add 5 to and get the same number. So, but let's try it and see. What if I subtract 7x from each side? What does it look like? It's going to look like negative 3 is equal to 5. That doesn't make sense. There is no solution. Okay. And then let's look at number 3 down here. 7x minus 3 is equal to negative 3 plus 7x. This is the same as 7x minus 3. If I just use the commutative property to move these into new places. Okay. But let's check ourselves. Let's subtract 7x from each side. If I do that, I get negative 3 is equal to negative 3. Okay. In this case, this is exactly the same, so there's an infinite number of solutions. Infinite number of solutions. Okay. Try the next page. Now, let's try this one, number 4. If we try this, let's see. Let's solve the equation so we can see what's on each side. I've got 11x minus 2x that I can collect like terms. That's 9x plus 15 is equal to 8 plus 7 is 15 plus 9x. This equation is exactly the same on both sides. So that means I'll have an infinite number of solutions. Just to prove that, let's subtract 9x from both sides. And I've got 15 is equal to 15. And that means we've got an infinite number of solutions. Okay? That's A is equal to A. Let's look at the next one. What if we distribute this? I've got 3x minus 42 plus 1 is equal to negative 4x plus 5. Okay, the coefficients in front of the variables are different, so it should have just one answer. So let's say 3x, negative 42 plus 1 is negative 41, is equal to negative 4x plus 5. Let's put the variables on this side and the numbers on that one. So let's add 4x to both sides. And I've now got 7x minus 41 is equal to 5. Let's add 41 to both sides. 7x is equal to 46. Divide both sides by 7, and x is equal to 46 sevenths. I don't need to simplify it. I just need to know that if there's one solution, that solution is 46 sevenths. Okay, let's look at number 6. Let's simplify this one. Okay, I'm going to collect like terms. I've got negative 10x plus 32 is equal to negative 2 times 5 is negative 10x. Negative 2 times 10 is negative 20. Okay, notice your coefficient is the same thing on each one of these. This you're added 32 to, this and you're subtracting 20 from. This is not going to work. They're never going to be equal. There is no solution. But let's just check to see. Let's add 10x to both sides and see what we get. I get 32 is equal to negative 20. If 32 is equal to negative 20, that tells me there is no solution. All right, and then this one, there's a fraction here, but it's not a problem. 1/2 times 8x gives me 4x. 1/2 times 26 would give me 13. Is that equal to 13 plus 4x? Yes, it is. Those two equations are exactly the same. Everything's going to be a solution, but let's just check to see. Let's subtract 4x from each side, and this gives me 13 is equal to 13. There's an infinite number of solutions. Okay. And let's see if we can get to this next one. Now it asks us to write two equations that have no solutions. Okay, if they have no solutions, they're going to have the same coefficient in front of the variable. Like something that's got 2x in front of the variable. What if I add 3 to this side and I add 5 to this one? That would give me no solutions. Or what if I use the coefficient of 3x? On this one, what if I subtracted 2? And on this one, what if I added 5? This wouldn't work because the variable and coefficient are the same, but what I'm doing to it's different. Now write two equations that have one unique solution each. That means my variable and coefficient will be different on each side. So how about 2x plus 3 equals 5x plus 7? See, variable and coefficient are different. How about x plus 1 equals 2x plus 1? Look, variable and coefficient are different. That's 1x, that's 2x. Write two equations that have infinitely many solutions. They'd be exactly alike. 2x plus 3 equals 2x plus 3. The equations are exactly alike. 5x minus 7 equals 5x minus 7. Okay? We've just determined whether equations have one solution, infinitely many solutions, or no solution.